solve some fractional equations, shall we, Mr. Haas?
Yeah.
All right.
Love fractional equations.
So this is an equation because
it's got an equal sign?
It has an equal sign.
Yeah.
And it's fractional because
it's got something over something?
Yeah, they're fractions.
Yeah, they're fractions, yeah.
Pretty basic, right? So we're going to solve this. We're going to solve for x. We want to figure out what x value, when I plug that in, when I substitute it in for x, makes this true. All right? Now, we've seen these before. This is a proportion when you have a fraction equal to a fraction. I'm going to solve this in two different ways. What do you think about that?
Well, I know what my students would want to do, I think.
What would your students want to do?
I think they're going to say cross-multiply, which is kind of a vile term, I always think.
Yeah, it's a little, I like saying the product of the means equals the product of the extremes. Have you heard that one?
I have. Yes, believe it or not, Miss Stewart, I have heard that one.
So.
I do teach math, you know.
You do?
Well, yeah.
Oh, okay. Well, there you go. So, let's do that, okay? But you're right. You guys like calling that cross multiplication, which Mr. House and I don't like because
then when they see two fractions being multiplied, they want to cross multiply, or divided, they want to cross multiply.
Yeah.
And so it's like, all right, you can say cross multiply, but you have to realize the one and only time that you can cross multiply is when you have a fraction equal to a fraction. That's it.
That's it.
That's it.
That's it. All right. So here we go. Should we cross multiply?
Let's do it.
All right. So here we go. Product of the means equals the product of the extremes. So here we go. I guess I should do the means first. So that's 2 times x equals 4 times x plus 5. Not too bad. I think I'll distribute that 4. Tell me how I'm doing.
Yeah, that looks pretty good.
All right, good. 4x plus 20. And then I'm just solving for x. So I want to pull my x's onto one side and everything else on the other. I think I can do that pretty easily here. Subtract 4x from both sides. 2x equals 20. I'm liking the look of this.
It's a negative there, right? Negative 2x.
Oh, thank you. See? Good thing you're here.
Yeah.
To get x by itself, now I'm going to divide by that negative 2. Running out of room, so I have x equals negative 10. I have solved that.
Yeah. Does that work out?
I think so. Let's check it. Let's check it. I always like checking these things. That's what's so nice about solving equations. It's easy to check. I'm just going to substitute in for my x what I think the x value is. And then again, substitute it in for that x. And let's make sure I get the same thing. Negative 10 plus 5. Negative 5 last time I checked. Negative 10 over 4. Well, heck, that simplifies to negative 5 halves, right?
That works, absolutely.
So I'm thinking that works. If you guys used your calculators, your calculator would give you negative 2.5. Same thing. Check.
Yeah, that works.
Successful. X, in fact, equals negative 10.
That's great.
All right. Let's solve this another way, shall we?
All right.
Fantastic. So I'll keep that same proportion there. But one thing I love about math is that there always are tons of different ways to solve problems. So here is another way I could solve this. All right, I'm going to erase it. Am I going to remember it?
I hope so.
X plus 5 divided by 2 equals x over 4. All right. So here's another way we could solve this. I have fractions. Could I get a common denominator there if I felt like it?
I think you could.
I think I could.
I like going for the common denominator.
I like doing that too. I like it. Because that's a strategy that will serve you in virtually every rational or fractional equation. What would be a nice common denominator there, Mr. Haas?
Well, let's go with 4. How about that?
All right,
yeah.
Fantastic. Because 4, of course, is already 4. I can easily turn a 2 into a 4 by multiplying it by 2. Of course, whatever I do to the bottom of a fraction, I have to do to the top of the fraction, so I don't change the actual value. We've talked about that already. So here I need to distribute that 2. So I have 2x plus 10. This, of course, doesn't change. Now, here comes the fun part. I can either do a logical leap or I can do an algebraic step. The logical step here, the logical leap is to say, hey, if this fraction equals this fraction, and this denominator is the same as this denominator, what must be true about the numerators?
Well, they've got to be equal too.
They've got to be equal to each other as well. Boom! Leap of logic. Math is about logic, so that is totally legal. Now I use my algebra to finish this. I have the 10 over here, so I think I might as well move my x's over to the right. So I'm going to subtract. Boom. So I have 10 equals negative x. Almost there. So I have x equals negative 10. Is that what I got before?
No, this is different.
No, that is what I got before. X equals negative 10. That's what I got before.
It is?
Yes, it is.
I thought, really?
Yeah.
I thought, okay, no, you're right, you're right. It was the check that was different.
It was the check.
I see. I thought you had, okay.
I know.
Right.
You're trying to throw me off.
No, I'm sorry, mister. No, you're absolutely right.
So I get the same answer. Boom. I got a common denominator. Then I was able to use a leap of logic. Okay? Now, I mentioned that there's another way to do that. Let's go back to this step. Let's recreate this step right here. Okay? So let's pretend I got the common denominator. I'm here. Here's a second method. Okay? We've talked about this at the beginning of the year. Whenever you have a fraction in an equation and you want to kind of get rid of that fraction, remember you can always do a tried and true thing, which is multiply by the denominator, right? So in this case, I'm going to multiply both sides by the denominator, which is 4. If you like, I can think of that as 4 over 1. Okay? So I'm multiplying a fraction times a fraction. We've talked about this a lot. That's the numerator times the numerator, the denominator times the denominator. And of course, I can divide as well. I've got a 4 in the numerator, a 4 in the denominator, so those divide to equal 1, and I'm left just with 2x plus 10. Same thing here. X times 4 over 4 times 1. Hey, I've got a 4 in the numerator, 4 in the denominator. Those divide, and I'm left just with x. And I think you will see that I am where I was here.
Yes, and in fact, it is going to be x equals negative 10, and I'm sorry I said something.
It is, in fact, going to be x equals negative 10. Isn't that fun?
Yeah.
Yeah. All right, let's do one more.
All right, let's do it.
Here's another fractional equation. I could actually call this a rational equation because I've got some variables in the denominator.
Yeah. Oh, that one's like way trickier.
Yeah, isn't it? Right.
Look at all that stuff in there. The x's and the 6.
Hey, remember whenever you have a variable in the denominator, you always have to make sure that the math police aren't going to bust down that door. What do you have to always keep in your mind? What can x not equal?
Well, the denominator can't be 0, if that's what you're,
That's
what you're going for.
Going for.
Right.
And
in
so
this case, you're right.
In this case, x then can't equal 0 because that was created.
Yeah.
All right, I just had to say that.
All right.
Because I don't want to be interrupted by math.
No, you do not.
So, I don't think I can do my product of the means equals product of the extremes because I don't even have a proportion. I don't have one fraction equal to one fraction. I've got 2 terms over here. So I'm thinking my second strategy is going to work nicely here. And that is to get a common denominator everywhere and then go from there. Okay. So I've got a 2x, a 6, a 3x. Are you thinking what I'm thinking in terms of a common denominator?
Yeah, I think you could pretty much you could go for a 6x perhaps.
Beautiful.
Yeah.
So I'm just going to get a common denominator of 6x everywhere. And of course I have to multiply each fraction by a handy form of 1. So let's see. I need to multiply 2x times a 3 to turn it into a 6x. So I multiply its numerator by 3. And there we go. This little guy needs an x. So I multiply the numerator and the denominator by x. Okay? This little guy needs a 2, so multiply denominator and numerator. I'm going to remember to put parentheses around there. Because, of course, I need to distribute that 2. That gives me 2x plus 2. So far, so good?
Yeah, looks good.
All right, so now you guys can decide. Either make your leap of logic. I'm going to do the algebra because I'm a big fan of algebra as well. Remember, whenever you have a fraction, you can always clear the equation of fractions by multiplying by the denominator. Of course, you have to multiply everything on both sides by that denominator. You have 2 terms here, so you have to multiply both of those by 6x over 1. Hey, what's going to happen, though, when you're multiplying 6x over 1 times 3 over 6x?
Yeah, you can divide out that 6x over 6x is just 1, so you just get rid of them from the bottom there.
Beautiful.
3, yeah.
What happens when I multiply 6x over 1 times x over 6x?
An x.
An x. Beautiful. And here, I'm multiplying this term times this term. Again, your 6 and your x divide out. You're left with 2x plus 2.
So really, Ms. Stewart, like once you get the common denominators, you're just solving the top.
You're just
right?
solving
Okay.
the numerator. And there's the leap of
You're
logic.
just kind of showing algebraically why you're allowed to do that,
Exactly
right?
right.
Is that okay?
Exactly right. Yeah, basically what I was saying before. If this plus this equals this, and all the denominators are the same, you know the numerator, this numerator plus that has to equal that. And now I just solve for x. I think I'm going to bring my x's over to the right. So let's subtract x from both sides. And my numbers over here. Let's do this in one step. So I have a 1 left over here. I have an x. And I think my work here is done.
Let's see if it works.
Let's see if it works.
Check it.
Check. Okay, here we go. Let's substitute in the 1. So 2 times 1 plus 1 over 6 equals, or should equal, 1 plus 1 over 3 times 1. Let's see, that's 1/2 plus 1/6, right? Oh, I'm going to have to get a common denominator here. Okay, 1/2, isn't that the same as just 6?
3/6.
3/6?
Yeah.
Plus 1/6, which is 4/6. Here's 2/3. Are those equal?
Well, sure.
Yeah, that simplifies to 2/3. Beautiful. Love that. Of course, if you had done this in your calculator, you would have gotten 0.6 repeating, which is the same as 0.6 repeating.
So
1 is my answer.
now, Ms. Stewart, you said something about the math police before. So when you're done with these, right? I mean, you just want to absolutely make sure that your solution of 1 does not make the denominators 0 if any of them. Is that right?
Thank you for saying that. That's really an excellent point. Whenever you finish, when you're doing your check, you do want to make sure that that 1 is not going to produce a 0 in the denominator. And if it does, it's not a solution. Yeah.
Nice.
Very nice. Thank you, Mr. Haas.
Just because the way